So we have seen already uh, the basic notion of kinematics, like basic definitions, and we learned two things. One is the average of every definition and the instantaneous of every definition, and we also saw the similarity between the magnitude of velocity, instantaneous velocity versus instantaneous speed, and we found that these two quantities are actually same. So instantaneous speed is equivalent of magnitude of instantaneous velocity. So all the notion we learned in a general scenario called the two-dimensional or three-dimensional scenario, or you can say the vector form. So similarly, can we write the equation of motion, the kinematical equation uh, for constant acceleration in vector form? Although we have written it before also, but we can actually write these equations in vector form. Okay. So today we'll see those equations in vector form, and then we'll go for the motion in one dimension. So we'll start that way only. Just oh, Harshit is calling. Okay. Okay. So what what we are going to do is we are going to write the kinematical equation, which we already know, but in vector form. So I think we have done this in vector itself, right? So if a vector is constant, then we know that a vector we can write as dv vector by dt vector. So this implies dv vector equals to a vector multiplied by dt, and you can actually integrate this vector directly. So this turns out to be the dv vector becomes from initial vector we can say u vector to final called v vector. On the right hand side, the time will go from 0 to t. Now, because a is assumed to be constant, so from the property of integration, any constant term we can bring it out of the sign of integration. On the left hand side, the dv will give you integration v vector, and we can integrate from u to v, and this will give you the upper limit minus lower limit equals to a vector into t, and so we get the answer v equals to u plus at. So this is the vector expression for the kinematical equation under the assumption that the acceleration is constant. Now the same method we also employ for deriving for one dimension. So there we remove the arrow sign and we proceed. Now it is actually not a very straightforward thing that how the integration of vector is similar to the integration of scalar. It turns out to be it is same by some advanced mathematical proof. So we are not proving that y vector integration is similar to the scalar integration because it's a complex topic. But we believe that the way we integrate numbers, like some variables, vector can also be integrated. And why this is happening? Because of the property of integration. Now, what is the property of integration? I'll tell you something. It's not very difficult actually, but so in integration we have studied something called the summation problem. So if we have multiple function, let's say if we have function f1, we have f2, we have and many function, and if you integrate, so integration follows the principle of linearity, which means you can actually integrate each term separately. Now this property of integration actually allows this integration to be valid. Why? Because every vector, see, when you write a vector, what you do not realize, because in last class also I discussed the same thing. When you write a vector, you actually write multiple variables. So if it is a two-dimensional vector, you write two variables. If it is three-dimensional vector, you write three variables. So every vector we can write as Vx I cap, Vy j cap, Vz k cap. And similarly, the A vector we can also write as Ax I cap plus Ay j cap plus Az k cap. Now, what you take as a granted, taken from list, these integration things are taken for granted, but it is not so simple. It's actually very complex. But it turns out to be mathematically equivalent. So let's say if I write everything in vector form, then I have to integrate three terms. So integration of dv actually becomes integration of dvx I cap. Then I can break it down into dvy j cap, and then break it down into dv z k cap. And now the numbers we can integrate from ux to vx, uy to vy. I'm just showing you why it is similar. Although it's not a simple thing that you can take it for granted. And then it turns out to be eventually vx minus ux I cap, vy minus uy j cap, and vz minus z cap. And this we can further write as vx I cap, vy j cap, vz k cap minus ux I cap, uy j cap, and uz k cap. And because we cannot rewrite this as again v and says u, that's why the integration is this much. So the idea is the integration when you apply for vector, it is not necessary that it will get something similar as you do for variables. But it turns out to be because of the property of integration, the linearity. This is called the linearity property. Linearity. So it turns out to be we can actually just write like this. Now you can see it's not very easy to actually derive the formula. We have to go through the entire complex derivation, and then we get this answer. But we can actually directly apply. So I have just shown you for one part. Rest part you can understand it's a similar thing. So okay, if you want, you can go ahead and expand, and then you can just check. So this is the formula, the vector formula of
So,
yes.
so that
Yes,
A vector in the left hand side is instantaneous acceleration.
correct, correct. So it is instantaneous, and if something is constant, it means the instantaneous value will be same as average value will be same as value for any average value for any duration. So if something is instantaneous, if something is constant, so it's the same every time, right? So no matter whether you calculate the average or you calculate the instantaneous, you will get the same answer. So we are going to learn on that something called uniform motion. And anyway, so the first equation we derive this, and how to derive the second equation. So all derivation comes from definition. Okay, so we are not supposed to think something from our side. It is naturally coming from the definitions. Now, because V is defined as dr by dt, and you're looking for displacement, so you can write as dr vector equals to V dt. And now I will not prove that how the answer is going to come. So we can integrate, and how we integrate. So let's say your initial location is R naught and your final location is R from the origin. This is how we write actually. And we have already proved for constant acceleration because we are again proving everything for A equals to constant. So we have already proved that we can rewrite as U plus A vector into T into dt, and the time is 0 to t. And then it turns out to be the dr becomes r minus r naught equals to because of a principle of a linearity, we can break down the plus sign, so we can write as u dt separately plus a t dt separately. And again, we know that u is a constant, u is the initial value, so which is always constant. So we can take a u outside, and then dt will give you just t actually, but anyway, I'm writing it. And then we have t dt expression. Actually, there is a branch of mathematics called vector calculus. Okay, so up to JE level, things are very straightforward. So it means the way you understand in variables, it replicates itself in a vector also. So it's difficult to see the difference between the two types of entity, vectors and variables. In advanced physics, everything changes. I mean, things are not so simple. So there is a completed dedicated book for only integration and differentiation in vectors. Okay, so you will study in maybe in BTech, you have to study a bit of it, not much. If you do the pursue the masters in mathematics, of course you have to study a lot, or in fact physics. So now R minus R naught. Now what I'm trying to give you the perspective that what you think is uh, obvious is not so obvious. Like things are actually very complex. So you may think that you're able to integrate vectors also. No, vectors integration is something huge. Like you have to first expand everything, then you have to check for uh, the validity of expression, and then you have to check for the okay, whether we can apply this or not. Then we can reconvert into vector symbol. Like so, first you convert vector into scalar, and then from there you go back to vector. Okay, anyway. So r minus r naught is ut plus a vector into t square by 2 is the integration. So we can also write as ut plus half a t square. Okay. So what you need to realize that when you write one vector, it it is like a packet of multiple variables. So a two-dimensional vector is a packet of two variables. One dimension is one variable, and three dimension three variable. The moment we come to one dimensional motion, the variable reduces to only one value, and therefore we remove the vector sign because we know that there is only one variable. Anyway, so these are two equations that we derive using the vector definition, and this we call displacement, right? R minus R naught is called displacement vector delta. Okay. So
So
we
that
can
r vector minus r vector is the difference of position vectors.
correct, correct. The difference of position is called displacement,
Displacement
right?
vector.
Yeah. So that's why we can replace that by delta R. So in the formula, S equals to ut plus half at square. What S represents?
Displacement vector. Certain.
Exactly. S represents displacement in one dimension, of course. So S is not the position vector. So if you want to write in position, we have to write x minus x naught or y minus y naught. And this is the advanced method of solving the question of this kinematics. So the way you solve in class 9th, you should not employ it here. Although you can solve, but it's good to avoid those ways of writing in fact. And now we learn slightly advanced ways of writing the same equation. Okay, so we'll write in terms of position vector. So we'll see that. Don't worry. So today I'll give you some theoretical aspect of kinematics. Okay, so what are the theoretical aspects? So now you know this basic formula. So we can go to the something which is very important. Okay. So the next concept is called uniform and non-uniform motion. Uniform and non-uniform motion. Okay. So when we say motion is uniform, when we say motion is uniform,
Sir, when its acceleration is constant.
no, acceleration will alter the velocity.
Sir,
So
when velocity
uniform,
is constant.
yeah, exactly. When velocity is constant, and for velocity to be constant, the particle must move in the same direction forever without changing its magnitude, or you can say speed. So when you say uniform motion, motion represents velocity. So velocity is the uh, the vanguard of motion. Like when you say velocity, it describes the motion. Acceleration disturbs the velocity. So acceleration is the it is going to change the velocity. So it will disrupt the motion. So when you say acceleration, you disrupt the motion. But you have also heard something called uniformly accelerated. Now, uniformly accelerated means you're disturbing at constant rate. It's not like it's uniform. And why you said the acceleration as uniform or constant? Because you have heard this phrase somewhere: uniformly accelerated motion. So when we say uniformly accelerated, and then we say motion, you have to read like this: uniformly accelerated motion. So there is a pause. So uniform acceleration refers to you disturb the velocity, you change it at a rate which is constant. That's the idea of uniform acceleration. If it is non-uniform acceleration, you're still changing, and you're changing with some different pattern, non-uniform pattern. But in both cases, whether acceleration is constant or variable, the motion is non-uniform. The velocity is changing. So uniform motion refers to constant velocity, not to do with the acceleration. Okay? Acceleration is anyway changing the velocity. So it's very easy to define. Let's just put in words. So what I can write? So a body is said to be moving in uniform velocity. Okay, with uniform velocity. Okay, is the representation of uniform motion, right? Okay, something like that. And what is the meaning of uniform velocity? Can you explain? What is uniform velocity?
So uniform velocity.
What is uniform velocity?
So velocity in which the particle has to move in a single direction, means in a only one direction, and will not change its magnitude, can be termed as uniform velocity.
So how we are going to measure it? Like how I will come to know as a experimentalist or observer that okay, you're moving uniformly, because velocity you cannot see, right? Can you see velocity?
No, sir.
No. So as a human being, I have explained it. There are only two observations which is possible. One is the displacement, other is time. So if we have a meter scale, I can measure the displacement on a meter scale. And if I have a stopwatch, I can measure the time interval. So now everything else we can calculate from here actually. So the fundamentally the dr and dt are the fundamental variables, and I have explained earlier also that dr by dt is given a fancy name called velocity. What is fundamental is dr and what is fundamental is dt, and the ratio, the rate is a fancy name called velocity. I mean, you could have said something also. So maybe the literature goes this way. So we have this fancy name velocity. So let's say if I give you something very fundamental, just a meter scale and a stopwatch. So how will you make sure that the things are informed? What are the parameters you will go up? I mean, across to uh, get this fact right. Okay, so the answer is simple. If a body travels equal displacement in equal time interval, however small be the time interval, then the body is said to be moving with uniform velocity, and such motion we call uniform motion. Otherwise, non-uniform. That's simple. Now, I have used the word if a particle travels or traverses equal displacement in equal time interval. So when I'm saying displacement, so I'm talking about vectors only. So for displacement to be equal, the direction must be equal and the magnitude also. In equal time interval, so I will also give you equal time. So if the motion is really uniform, then in equal duration, you must have equal displacement, right? Now, if the duration is large, then this is not true. Why? So let's say if I give you 1 hour to go from somewhere to somewhere. So you may drive very fast for some time, then very slow for some time, then you manage the 1 hour and you reach the destination, right? So if I give you large duration, you can manipulate the speed and still manage to reach in the same time. The other guy can go really slow for some time and then really fast. So for large duration, you can manipulate the velocity, I mean the magnitude to manage the displacement. Now, if I keep on shrinking the time interval, that variation could not be possible. So let's say if I make the time interval really small, maybe tending to zero, and if I find that okay, the displacement in that duration is same, like if I break down the entire journey in 1 second interval, let's say, and I found that okay, in every 1 second you travel equal displacement. Now that will kind of confirm that you are moving uniformly. But mathematically, if I make the time interval tending to zero, if every dr in every dt turns out to be same, we can say it's uniform motion for sure, because we have found this event true for the smallest interval, so it is bound to be true for the bigger interval, right? So if something is true for almost zero interval, then it must be true for a larger interval, isn't it? Do you realize what I'm saying?
Yes, sir.
Yes, sir.
Sir, I have a doubt.
Yeah.
Sir, in it's like space motions, like long distances, they also
Yeah.
use these mechanisms, dr by dt and all.
Why they will use dr/dt by the way?
So for calculating any velocity and all or acceleration.
Uh, in space, they cannot calculate the velocity. They know the velocity in advance, because to calculate velocity, you need to measure the displacement and time. And displacement and time, you need some origin to observe. So in space, you can't see origin, right? You cannot see something related to your moving. So the motion is only meaningful when you have something environment you can see. But in space, however fast you may be moving, you cannot realize. So for you, you are at rest. Like the sense of motion is not there actually. Like I will tell you something very simple example. You have taken a flight many times, and when flight is moving at a tremendous velocity, let's say 1,000 km per hour, do you feel 1,000 km per hour? Answer is no. For you, the clouds are moving very slowly. It is like boring. Why it is not moving? And imagine if there is a clear sky, then the sense of motion is also not there. Sometimes we derive the sense of motion from the sound vibration of the vehicle. Sometimes we feel it by looking at the surrounding. And if all these things are missing, so our sense will not work. So for us, the motion is only as long as we can see some changes. So those who are, let's say the fighter pilots, they are moving really fast. But do they feel they're moving fast? The answer is no, they don't feel. And that is why they are in control of the flight. So they are not feeling disturbed by all this speed. So their brain is at ease within the cockpit. Okay, they don't feel much of changes. So imagine that the spacecraft going from one planet to another planet, do they feel anything? The answer is no. So they have the advanced calculation of direction, and it is controlled from the Earth. So they get the information from Earth that it's going away and away and away. So those inside don't know how fast they are moving, to be honest. Only on Earth we give the signal through the electromagnetic pulse. They receive the signal, they understand, okay, the spacecraft has attained this speed. So all the communication from the Earth is happening. They have no idea how fast they are moving, and they cannot get the idea because you need some measurement. Let's say your car is giving you reading. Why? Because the wheels are connected with a rotatory motion, and the number of rotation of the wheel gives the count of how much you have gone ahead. So the speedometer gives you the wheel rotation, not the speed of the car. So now you may do one thing. You can just put your car on some ramp and rotate the wheel. You can see the speed, although it's not going anywhere. The idea of speed or velocity is always relative. You need some kind of origin to measure it. In the outer space, things are very complex. All the concept, the notion of speed will vanish. You cannot feel motion at all. Can you feel motion in a dark room? Let's say if everything is dark everywhere and you're moving, can you feel the motion? The answer is no. You cannot feel the motion. It's very complex. So do you feel that the plane is moving at 1,000 km per hour? You cannot feel. But even if you're riding a bike in your lane at a speed of 10 km per hour, you can feel it's moving really fast. So you may feel a 10 km per hour is really fast, and you fail to feel that 1,000 km per hour is really slow. The idea is the feeling do not justify the motion. And that was the precise idea behind the Einstein theory of relativity. And that guy was able to feel something more than us. So he felt something beyond our imagination, and he created something unusual called the theory of relativity. Okay, Nikhil. Let's go further. You need to realize many things. I mean, as you will progress, kinematics is a huge branch of physics actually, and in India we teach as a chapter, but it is an undergrad part. Like in undergraduation, you will learn the kinematics as a principle of a relativity only. So when you start learning relativity, maybe if you're pursuing the masters or bachelors, so the relativity begins with the kinematics only, and then they'll break the idea of your origin and all. So you will get disturbed. Okay, so the entire your notion will be totally disturbed, and I'm not trying to disturb you right now. So if I say something more, you will get disturbed also. Anyway, so let's go ahead and define it formally, as we should know. So a particle, a particle moving in such a way that it travels equal displacement in equal time interval. Now here comes the catch. However, small be the time interval. So particle moving in such a way that it travels equal displacement in equal time interval, however small the time interval, then it is said to be moving with uniform velocity. Else non-uniform velocity. So let me write a note. Uniform motion refers to uniform velocity. Okay. Okay. So this is a very important notion. When you say the word uniform, it only refers to velocity. Nothing to do with the acceleration is actually changing the velocity. So when something changes, it is against the law of inertia. Inertia says something to maintain, right? And something changing means its inertia is changing. And so you will come across something called, there are two types of frame of reference, inertial frame and a non-inertial frame. So we say that a frame of reference is inertial if it is either at rest or moving with uniform velocity, because the meaning of uniform is velocity only. So if someone is maintaining the inertia, they are inertial frame. Someone is not maintaining the inertia, it's called non-inertial frame. And the laws of physics are different in these two frames. And that is all about our next chapter, laws of motion. Okay. So Einstein went much ahead of this concept, and he said, okay, not only law of inertia, he said that the law of physics, entire law of physics in the inertial frame and in the non-inertial frame are totally different. Now imagine up to what level we have to study to go into the other part of the physics. So to learn the non-inertial physics, you have to do at least PhD. That's the where you will start learning about the non-inertial frame and the physics in that frame. But it's not only that's the beginning part. You learn the basic of that concept there, and then you have to do the postdoc and many postdoc to become a physicist of that stature, which will go into the dimension of non-inertial frame. So we have something very advanced physics, like physics is into various parts. So what you're learning is called the Newtonian physics. Like what I'm teaching you is called the this is called Galilean transformation. So this is the advanced way of saying this. So we have Newtonian physics, we have Galilean transformation, then we have the Einstein, like the relativistic physics, then we have the Lorentz transformation in that world. Okay, and then we go to the quantum physics, then we go to the quantum chromodynamics. So we have eventually we'll go to the string theory. That is the end of the dimension of physics. Physics will end there. So the entire physics, if you just go to Wikipedia and you can search what are the level of physics, so we'll come to know that physics is going from one dimension to other dimension, and then we have different frame of reference, and things are not what you believe may be true. So as you progress in physics education, you will see that it is becoming more and more complex and mathematical. So only class 12 physics is easy. Like what you're learning is the fundamental thing. After this, there is no physics. After this, only mathematics. Okay. So the difficulty will rise because of maths, but the conceptually things are what you're learning in 12th is the end of the world of physics. Like I am saying you that physics from 12th is sufficient to win a Nobel Prize also. But you need to learn a lot of mathematics afterwards. That's the problem. So many students who think that physics is so juicy, so organic, let's go ahead and take physics. Okay, they later on get trapped in the mathematical world. So you need to be very much happy with the mathematics to actually pursue higher physics. Else, I will not recommend anyone to pursue physics. In fact, if you're a mathematician, you will anyway learn physics. So like the world best mathematician right now, the Terence Tao, he's much into physics actually. So he is trying to create something out of physics. Now, why physics is so interesting? The reason is mathematicians do the abstract thing, and physics is the real world. So when physicists, get stuck in some kind of mathematical complexity, they go back to mathematician, and they are having already the abstract idea ready with them. So physicists will put that into use. So it's like you're creating mathematicians are like creating a product which is of no use unless a physicist come to buy it. So you are selling something, but there is no buyer. The only buyer you will get is the physicist. Okay, anyway, that's close. Going back to the basics. We are learning kinematics. Come on, we are not learning something advanced. Something very simple we are learning. So let's keep it. So in case of uniform motion, what you can say? Because motion is uniform. In case of uniform motion, the average velocity or instantaneous all will be same. There is no difference. So you cannot differentiate something. Both are same actually. And therefore, the formula delta r by delta t will be valid. And therefore, the delta r we can also rewrite as v delta t, the direct. And this is precisely what you learned in maybe class 6, distance, speed, time formula. Distance equals to speed into time. Okay, so that formula was kind of uniform speed formula, not a formula in general. Anyway, so delta r equals to v delta t. Now you must understand that the class 6 formula that we learned s equals to vt, when it is valid, it is only valid when v is constant. Okay, then you can write like this. Else you cannot write like this. That's the idea. So delta r is v delta t. Okay, and this is the case of uniform motion. So when we have acceleration, can we apply the same? When we have acceleration, can we apply
No,
the same?
sir.
No. When we have acceleration, it's non-uniform motion, and therefore it must have a separate formula, which we have already seen. So we have this formula. You can see this. So if you put a equals to 0 in the our formula, if you put a equals to 0, this turns out to be same as what we just derived. You can see it's the same thing. So this is a more general formula, but even this formula is having limitation. What is the limitation? The a must be constant, right? If a also becomes variable, then even this formula we have to discard. We have to go back to this formula. Yeah, we have to go back to not here. We have to go back to the integration something on the previous page. So if even a becomes variable, we cannot we cannot go beyond this. So this will be not true. We cannot take a outside because a is a function of time. So a will remain inside the integration, and from there you have to rederive some new formula. So this formula will not come. This will not come. What we'll get is something new actually. That's called the variable acceleration. Okay, I hope you are getting the point. So things are not just black and white. So we have many gray shades in kinematics, and the beauty is realizing those gray shades. And then perhaps you will find very easy if you go for advanced physics, like understanding the relativity won't be that difficult. Okay. Anyway, so let's go further. Okay. So in case of uniform motion, the instantaneous velocity is same as average velocity, and you can write that this equation, and so you can write this equation. Okay, and I have written otherwise non-form. Now there's something very interesting.
Sir, I want to note that last part.
Just Then, and please keep an eye on
Yeah.
what I'm saying. There are many subtle differences that you will see during the lecture. So keep your eye and ear open so that you can absorb those subtle differences. So kinematics is very easy topic, but the small differences will make it really interesting. Okay. So the next part is called non-uniform motion. So now the non-uniform motion can further divide into two categories. So we can divide this into two categories. Uh, so the first is called uniform acceleration. So uniform acceleration means A is constant and non-zero. In such case, you will start with this equation, and from this equation you can actually derive all other equation, which is called the kinematical equation. So you will get all the kinematical equation which we have already discussed. Okay, but something more deeper we can actually understand here. What is something more deeper? Because it's uniform acceleration, it means the acceleration must have same direction, right? So acceleration is not changing the direction. Getting a point? Acceleration is not changing the direction. So magnitude wise and direction wise both A is constant.
Sir, then
I hope.
if centripetal is like it is constant only.
No. There are two possibilities. I will tell you. When A is constant, then there are two possibilities. How you throw the object? Do you throw along the acceleration or at some other angle to the acceleration? For example, imagine this is the acceleration. Let's say you can think of gravity, but I'm not adding gravity. I'm saying let's say acceleration is this way, and then you throw some object this way. Now the rule is if the velocity of projection, or you can say the initial velocity, not necessarily projection, if the initial velocity and acceleration are not collinear, then it results into 2D motion. Understood? So when two-dimensional motion happens, when u and a are non-collinear, in such case the path will be parabola. Now this is thumb rule. It is not only about gravity. I'm saying whenever, if the acceleration is constant, this is the first condition. Whenever acceleration is constant and you are projecting some particle with a velocity which is not collinear with acceleration, the path will be always parabola. It is not only about gravity. Any other acceleration, any other situation, the path will be parabola only. I will prove that. Why? We'll see in the chapter of projectile motion. It's not a big deal. So first thing you need to remember is that if u and a are non-collinear, it's a condition of 2D motion and the path will be always a parabola. Now what happens if a and u are collinear? So maybe either this way, it's also collinear, or you can say parallel also, not needing to say collinear, or even the same direction. You can say this way also. Whatever be the case, when acceleration vector and u vector
Sir, one dimensional motion.
Yeah, so this will result into one dimension motion. So one dimension is all about the initial velocity and acceleration. So to understand the motion, that how it is going to happen, just look at the initial velocity and acceleration, rest will be decided automatically. And now comes the two name. If u and a are opposite, we say deceleration. So to understand that a motion should be called accelerated or decelerated, what we check for is the u and a direction in the beginning. And if it turns out to be same, we say accelerated. I'm not using the word acceleration, I'm saying the word accelerated. So in fact, I should write here decelerated. Just a minute. Decelerated. And this is called accelerated. So both are acceleration, but the when u and a are opposite, we call decelerated motion. When u and a are same direction, we say accelerated motion. So there's nothing called sign convention. You can say up as plus and down as minus, or vice versa also. That doesn't matter. Yeah, for solving numerical, we stick to some convention so that we can write it easily. But what is the essence of accelerated or decelerated motion? It is the direction of u and a. If u and a are same in the beginning, or what we look for is beginning, that's it. We call accelerated motion. If u and a are opposite in the beginning, what is happening later on doesn't matter. If it is opposite in the beginning, we say decelerated motion. Okay. And if it is two dimension, we only say word accelerated. We don't use the word decelerated because it's two dimension. And in this case, the path will be a straight line.
1D.
Yeah, correct. So now you understand when the path will be straight line, when the path will be uh, two dimension. Okay. So even when the motion is non-uniform, then these are the things that we need to be careful about. We need to understand or analyze and differentiate these events. And when you are able to differentiate the event, actually you can see the mathematical relation already, which is present there. So let's go to the next part. The next part is non-uniform acceleration. So how we proceed to solve question which involves non-uniform acceleration? So the idea is in non-uniform acceleration, although it's non-uniform, but it should follow some mathematical equation, some mathematical function. So I am believing that although I am saying the word non-uniform, but it is following some mathematical function so that we can integrate. If it is really random, we cannot write any mathematical equation. So if acceleration is random, you cannot do anything. If A is random, no mathematical pattern possible. So what we say? This is called the Brownian motion. You can say, you may say Brownian motion. Not Brownian, that's not even. But it's something random. So we can use we can invoke the statistical behavior. It depends on system also. That's okay, leave it. Now, if it is not random, I'm saying it's non-uniform, but I'm saying it's not random. It is having some mathematical pattern. So if A follows some mathematical function, so that will be given to you, need not to worry. So if A follows some mathematical function, I'll just put this part in bracket. This is, so if A follows some mathematical function, there are three types of function you will come across in physics. So what are the three types? So you will always start with the definition. This is the fundamental thing, because this is always true no matter what. So whether some condition is given to you or not, you can always begin by writing A equals to dv by dt. This cannot be like incorrect. This is always correct, because this is something very fundamental. So if A is following some mathematical pattern, so A is non-uniform. So when we say A is non-uniform, we say A is non-uniform if it, because if we are saying that a vector is non-uniform, so what does it mean? The vector is changing either its magnitude or direction or both. That's it, isn't it? So when you say acceleration is non-uniform, then there are three possibilities. So it can be non-uniform only by changing direction. Now suppose if the acceleration is non-uniform because it is changing direction all the time, only changing direction, so I'm not changing the magnitude. Now such situation is called centripetal acceleration. I think we have discussed in the last lecture also. So we say this as centripetal acceleration. If you're only changing the direction and if you're keeping the magnitude constant, so this is probably the case of, I'm saying this is probably the case of centripetal, but not necessary. That's why I'm not writing anything. If it is only changing magnitude, then it is a possibly a case of tangential acceleration, but I'm again saying not necessary. You may have a situation in which things will be complex. So here the acceleration is changing only by changing the magnitude. Okay, direction is constant. Okay, and the third is both changing. Both means both magnitude and direction changing. Okay,
Sir,
so yeah,
sir, these are the cases for which a vector can be expressed in the form of dv by dt.
see, A equals to dv by dt is always true no matter what. That is the beginning. Okay, even if for this case also we have A equals to d by dt is the definition, so that cannot change. No? Definition is the fundamental. What is most fundamental? Definition, which never changes. Okay, now when you derive some formula, you begin with the definition and then you put the constant which you know already to go further. What I'm saying is, if it is random, then you cannot go further because you have no idea about V, actually the pattern of V. Understood? So whatever be the pattern, the equation is true. I got your point. So even though V is random, you have no idea, but the relationship is true, no? Can we
Yes.
change A equals to d by dt to something different? No. Now definitions in physics are the fundamental, you can say, the basis on which we built the bigger formulas, the other derivations, everything start from there. Now, when you learn definition wise, you learn by the first principle. This is called the first principle of learning in science or mathematics. So you have to understand what is first principle. The first principle is begin with the definition and proceed as the things are given, whatever constraints are known to you, and then you arrive at the formula. So formula is not important. What is important is the definition. Now, generally, what happens, I have seen, in fact, that's my experience. 99% students do not stick to definition and they only go for formula. Now, in such scenario, it's difficult to crack the tough exam like JEE with good rank. You may crack with a rank of 2000, 3000 like this. But if someone is trying to be in the top 1000 rank, the first thing is you will learn by the first principle. Only those who are able to learn by first principle can crack the JEE with much ease. Like I'm saying that I know many students, uh, not very hardworking, just they were relaxed, studying, solving question on a regular basis, and they get a rank around 400, 500 very easily. Like I'm saying, not with much rigor, with ease actually. Why? You need to be very calm within, because when you calm, then you can absorb the events easily. Don't create the chaos in your brain. Keep calm, breathe the definition, and exhale the formula. If you can achieve this task, physics will be always a piece of cake for you. And always learn in keeping in mind that if you have to explain to someone else, can you explain it? So any concept which you think that you have understood, you should be able to explain to a sixth grader. And if you think that you can explain it to someone else, you have understood the topic. And that is the reason behind that everything you want to master, you have to explain to other first of all. This is the thumb rule. So if you have your siblings at home, some like someone who is in class 9th or 10th, always help them by explaining the things, and in that way you will learn better. Okay, that's a very uh, right way of learning actually, to be honest. Okay. Now similar to the acceleration, if it is non-uniform acceleration, so I'll go something beyond. So for non-uniform acceleration, I want to say something more. If the non-uniform acceleration happens in one dimension, then we have something very beautiful. So because that will be part of one dimension, so I will tell you in one dimension in how many category we can divide the non-uniform acceleration. So we'll see there only. Okay. So all the mathematical formula will come only for one dimension. In three dimension, we cannot have a mathematical formula because formula is relating one variable. If it is multivariable, then it's a really advanced concept called multivariable calculus. So that you will learn maybe in masters. So that calculus demands something more. It's called the n-dimensional calculus. That's not our syllabus. The BTech will only teach you the three-dimensional vectors up to three dimension, and that only a basic introduction. That's the part of BTech or graduation. And then if you go beyond BTech, if you go master, then you will learn the advanced calculus. Or if you do pursue only graduation in mathematics, like masters in mathematics, then you need to study something more. So those who graduate from the ISI, that is Indian Statistical Institute, they go to such a deeper level. Rest part of the India, it's not taught to that great level. I mean, I'm saying the rest part of India, including IITs and NITs and whatever. Anyway, coming to the next topic, which is again a theoretical topic. What is the meaning of uniform and non-uniform speed? Meaning of uniform and non-uniform speed. Now, can we say that if a particle is moving with uniform velocity, then it must have uniform speed? Can we say?
So velocity.
Yeah, if something is moving with uniform velocity, then it must have uniform speed. Is
Yes,
it
sir.
true statement or false statement?
True, sir.
Exactly. It's absolutely true, because the first one is the more stricter condition. If that is fulfilled, then the the lower conditions are anyway fulfilled. Yes, but the vice versa, can we say? Can we say if something is moving with uniform speed, then it must have uniform velocity?
So it can vary through direction. So hence we cannot say that.
Correct. So speed has nothing to do with the direction. So it is having the freedom to change the direction. So the moment that you start changing the direction, you may have uniform speed, but the velocity will change. So that's why it cannot be uniform. Okay, so the first idea you got it correct. So how to define the uniform speed? We have defined uniform velocity. Can you think on the similar line to define the uniform speed? What should I write here? Anybody?
Sir, a particle.
Sir, a particle is moving
Hmm.
that travels equal distance in equal time interval.
Hmm. And one more thing, one more condition was there, na? The however small be the time
However
interval,
small be the time.
and that is the mandatory statement. If you miss that statement, it's wrong, because I want this fact to be true for the smallest possible interval, because if something is true for the tiniest interval, it is going to be true for the big interval, isn't it? But if something is true for big interval, can we say the vice versa? Let's say if every person
No, sir.
travels one kilometer in let's say you walk 1 kilometer in 10 minutes, so can we say that you must be walking uniformly?
No, sir.
No, we cannot say that. That's impossible. I don't know whether you ran for some time and then you just stroll and then you were lazy sitting for some time, and then you completed 1 kilometer in 10 minutes. So in 10 minutes you can manipulate the motion to get it done of 1 kilometer. But if I reduce it to 1 minute, and probably if you can make it, then the chance of variation will be less than the first case. But if I make it 1 second, then things will be much more refined. Like if you're traveling equal distance in every 1 second, the chances that you are moving uniformly is very, very high. So if I reduce it to almost zero, and I make sure that you travel equal distance in equal time interval, however small the time interval, the time interval may shrink to zero. That will make sure that you are moving with uniform speed. Okay, so the definition is clear in your mind, and that's a really good thing. So I'll just mention this. A particle is said to be moving with uniform speed if it travels equal distance in equal time interval, however small be the time interval. Okay, otherwise non uniform. So a particle is said to be moving with uniform speed if it travels equal distance in equal time interval, however small be the time interval, otherwise non-uniform. Okay, so in such case, for uniform speed, for uniform speed, we write distance Although we do not have an exclusive symbol for distance, but from the context we know its distance. So I'm writing s only is equals to v into t. So you can always write like this. So s equals to vt is only true for uniform speed, but s is the distance. Mind you, s is the distance. So you can also write the v equals to s by t, like small school, high school formulas, and t equals to speed upon velocity. And to remember all this, we have a triangle method. S equals to Vt, V equals to S by T, T equals to S by T. You can see from this triangle, you can get all formulas, right? Okay. So some points we can mention here about uniform speed. So for uniform speed, can we say acceleration is zero? If speed is uniform, can we say acceleration is zero?
Yes, sir.
So how many of you think that if speed is uniform, acceleration must be zero?
So sorry, it can be not means. So zero,
Acceleration,
it can be zero, but with the direction like.
no, it cannot be zero. So we can't say zero. See, acceleration has to do with velocity, not speed. So if speed is uniform, it will never guarantee that velocity is uniform. And because it will not guarantee that velocity is uniform, it will never guarantee that acceleration is zero. So we cannot say affirmatively that if speed is uniform, acceleration is zero. But it may be zero. May is possible, like possibility is there, but necessity is not there. So you cannot make a affirmative sentence. Okay, but you can make something like what we say subjunctive. Okay, sentence. Okay, the possibility is there. Anyway, so let's write down if speed is uniform, then it will not guarantee. You can check the spelling of guarantee. I think maybe some mistake is there. It will not guarantee that velocity is also uniform. Therefore, it will not guarantee. What is spelling guarantee? Just can you check the spelling guarantee? G-U-R double R or A-N is fine. Guarantee. What is the
Sir,
spelling?
it's GUA.
G-U-N? No, I had this one. Something that yeah, tell me G
Sir,
A U.
GUA. And then the say GUA.
Okay. Then R-A-N-T-W, right?
Yes.
Yeah, that's correct. So then it will not guarantee that the velocity is also uniform. Therefore, it will not guarantee that acceleration is zero. So these are something called the MCQ problems, like uh, how strong you are theoretically. Like, can you answer these questions with ease? And if you are able to answer this question with ease, it means your concepts are really clear. So more than solving numerical problems, For JEE Advanced, one must be very good with the theoretical aspect and how clean you can think about it. Of course, it comes with time. But I'm trying to give you all the possibilities. Okay. Okay. Now, because for uniform speed, we already, I mean, we should have mentioned. I didn't mention. For uniform speed, for uniform speed, the instantaneous speed will be same as average speed that we know already. Okay. Now, what happens if it is a rectilinear motion? So if it is a rectilinear motion,
Then the velocity will be also uniform.
yeah, for rectilinear motion, with uniform speed, velocity will be also uniform if it is not changing the direction. So velocity will be uniform as long as you're moving in one direction. If you reverse it, it will change because if the right is positive, left will be negative. So rectilinear will also have a chance of acceleration if you're reversing the direction. Otherwise, it's a zero. So for rectilinear motion with uniform speed, velocity will be uniform for the given interval if direction is not reversed. Okay, because there is chance of reversal of direction. In such case, acceleration will be, so in such case acceleration will be zero. Okay. So now you can see that if you ask you some questions, let's say if I'm creating a question like this, is it possible for a body to have an acceleration with uniform speed? Yes or no? Is it
So can
possible
you
for a
repeat the question?
is it possible for a particle to have an acceleration and moving with uniform speed?
Sir, acceleration makes velocity.
Yeah. No, my question is simple. Is it possible for a particle to have an acceleration which is moving with uniform speed? Yes or no? That's the question. So this is the first pointer. This pointer is what I am asking. It is possible to have uniform speed and non-zero acceleration because acceleration depends on velocity, right? So you may be moving with uniform speed, but you are changing the direction. So you will have acceleration, right? Understood?
Yes, sir.
So if something is moving with uniform speed, it can have acceleration. So possibility is there, na? Is it possible or not? So answer is yes, it is possible.
So,
Yes.
so,
Yes.
so I'm not able to visualize the first point because if
Okay,
the
okay, okay.
direction,
No, it's very simple. Imagine something is moving on a circle. So imagine a particle is moving on a circular path. Maybe you are having a car, you're moving in a round track, and your car is showing the constant reading, let's say 60 kilometer per hour, that is always shown. So can we say you do not have acceleration? Because you are turning on a circle, then you must have the centripetal acceleration. And still your speed is constant.
Yes.
Got the point?
So, sir, in this case, tangential acceleration is constant
Zero.
and
Yeah, zero,
centripetal
zero,
will be.
zero, zeros. Tangential is zero. Uniform speed means there is no tangential acceleration. Uniform speed refers to zero tangential acceleration, but non-zero acceleration.
Yeah, sir, understood.
So when I say acceleration, I mean the total acceleration, and you should not think about only one particular component of it. So the reason for confusion is that you stick to only one component to derive your answer. If you think generally, the acceleration will have two components, tangential and centripetal. Think in this way, hopefully you will not find difficult. Okay? Okay, I hope this is clear to all of you. My next question is it possible to have zero velocity and non-zero acceleration? Is it possible to have zero velocity and non-zero acceleration? And you
No, sir.
guys have done many times. No, you guys have done this. No, that's the wrong answer. See, we always solve problem in class 9 that a particle start from rest and accelerates uniformly. So even the velocity is zero in the beginning, acceleration was there, no? Okay, let's think of this way. If you drop some object, what is the velocity at the instant of dropping? Zero. But what is the acceleration? 9.8 meter per second square. Now, acceleration should not be, thought as something which you can see. Acceleration is the ability to change the velocity. So I'm saying velocity is zero and ability is non-zero. Why not? Ability can be there. Ability may be there. So ability is there to change your velocity. So right now you're at rest, but I will change afterwards. Acceleration is about ability. It's not about motion. It's about the ability to change the state of motion. So something at rest may be given some velocity. Let's go back to the very basic notion of acceleration. When you write acceleration, let's say you're writing 2 meter per second square. Now, 2 meter per second square can be thought as 2 meter per second per second. Now, if you read this part carefully, you will understand what is the meaning of acceleration. It is trying to say that I am capable of changing the velocity by 2 meter per second in 1 second or per second. It means if you start from rest in 1 second, I will give you a velocity of 2 meter per second. I will change your velocity from 0 to 2 meter per second. So in 2 seconds, I will change by 4. In 3 seconds, I will change by 6. So in a given time, I can change by that action into that time. The change we write as AT. AT is called the change. So let's say your final velocity is V, initial was U. So the change is this much. And this change is equals to AT. And that's why you get the formula V equals to U plus AT. So it is saying that I am going to change by this value. That's the meaning of acceleration. What gravity is saying? It is saying that even if you release from rest, I will change your velocity by 9.8 meter per second. So after 1 second, you will have a velocity of 9.8 meter per second. After 2 seconds, I will change by twice of that. So if you begin with rest, then I will add that value. If you start with some value, then I will add to that value. The change is 9.8. If you realize this, you understand what is acceleration. Acceleration is always written as ability. I think you all got confused. Is this clear or confused, guys? Tell me.
Sir,
Do you have any confusion in this? Is this clear?
yes, sir.
Okay. So okay, if I write a question, is it possible to have zero velocity and non-zero acceleration? Answer is yes. So you can quote some example like to prove or to validate your claim. So I will write that when we drop any object, its instantaneous velocity is zero and acceleration is equal to gravitational acceleration. Now, when I say acceleration, it means that acceleration term will change your state of motion, your velocity by some value in per second. That's the idea of acceleration. Okay.
Sir,
Yes,
sir, how instantaneous velocity will be zero?
you're dropping it, no? So when you release some object, what will be the velocity at that instant? You can say instantaneous initial velocity. So if you release something from rest, what is the velocity? Zero, non-zero. So at the time of release, what will you say? What is the velocity? Or let's say if someone is moving, let's say your car is you're driving a car on a straight road, and the road is just the width of the road is good enough to just accommodate your car, and you want to turn back, like go back. So how you will go back? Will you go back by always moving, or you have to stop somewhere? So to put your car in the reverse gear, your car must be stopped somewhere. Or can we continue moving and come back? Is it possible?
No, sir.
So to come back, what is the condition? You must stop somewhere, and then you can come back. So when you stop somewhere, that's called the instantaneous velocity is zero. So whenever there is a reversal of direction in one dimension, the velocity is bound to be zero at that instant when you try to reverse. Is this point clear? What I'm saying? Whenever you try to reverse your motion in one dimension, you are supposed to stop first. So the point where we turn back,
A call from +918237990156.
so the point where you turn back will have the instantaneous velocity is zero. Is this clear? Clear or not?
Yes, sir.
Tell me that. All right. So this is done. So we have done most of the theory part, and so let's do some questions now. So we did one problem last lecture about displacement on a circular path. So we'll do something more. So today we are going to calculate the acceleration also, and yeah, yes, velocity also. So what is the question? Let me put the statement of the problem. So a particle is moving with uniform speed v on a circular track. So a particle is moving with a uniform speed on a circular track of radius r. Find find its average velocity. Find the find the okay. So you can read this question first, and then so idea is simple. You are moving on a circular track. So let's say you begin somewhere, and you traverse some distance on the track. You come here, and this angle is theta. This is r. Your speed is constant. So what is the average velocity for this journey? That is the question. Can you solve this question? At least try this question.
Sir, VR theta.
Pardon? So what is the average? Okay, okay, okay. When I ask some question, try to go back to definition. What is the average velocity, guys? Tell me.
The displacement of total time.
Correct. So what is the displacement here? We have, I think, calculated the displacement in the last
R
lecture.
theta.
Is that the displacement? Are you sure? Is that the displacement or distance?
That is the distance.
Correct. So you're supposed to find displacement, right? Not the distance. If you want to find the average velocity, you need first displacement. So what is the displacement for this particular path?
Zero.
Can you see that it's zero? I mean, it's obvious not zero. I mean, I can see it. Is the initial point and the final point of journey is at zero separation? Are you sure?
No.
Then why are you saying zero? So it means
Sir,
your concept of displacement is not there. Yes, tell me.
so is it VR theta?
I really do not understand what you're trying to find, why you're trying to answer the question with your own notion. I'm saying, why are you not following the definition? What is the problem in following the definition? You're supposed to find the magnitude of average velocity. What is the definition of magnitude of average velocity? You have to begin from there. So did you write the formula first? The average velocity formula? What is the formula for average velocity? Tell me.
So it is dv.
Don't say anything. Don't say just any random thing. If you do not remember, go back to check your notes and tell me the answer. What is the average velocity definition, which we learned in the last lecture? Can you go back and check? See, I will tell you the problem. The problem is you have been solving the question of class 9 with ease. Suddenly, vector has come into your life, and you're trying to, carry the same notion here also. And that is the reason behind all the mess you're creating now. So you haven't learned what I have taught in the last class. Your brain was closed kind of thing. Open your brain, learn the fresh thing, and then try to apply the concept. But this is happening, I can see it.
Sir, it's 2 hours sine theta by 2.
Yeah, it's 2 hours and theta by 2 is the displacement. Yeah, that's correct answer.
Displacement.
Yeah. Then what is the average velocity? So that upon time. So you have to divide by time, right?
Yes, sir. I was just telling the displacement.
Now think of time. How to get the time answer? And I hope you can get the time because we have learned about the uniform speed.
Sir, it's r theta by v. This is all the time.
Correct, correct. Very good. So that's the right answer. It is r theta by v. The average velocity modulus. The way I write, the way I read. So it's called modulus of average velocity. So first I will write like this. So first I will think of average velocity, which is delta r by delta t. Then I'll put a mod because I need mod of that. And this is same as mod of delta r because time is scalar. And this will be 2r sine theta by 2, which we have done already. And this is r theta by v. How? For uniform speed, we have just learned s equals to v. S is r theta, v is given, and you can say time. And so the answer is something very interesting. It's v multiplied by sine theta by 2 upon theta by 2. It looks really nice. Can you see that? So I have taken the 2 and I have brought in the denominator because to match the formula. So you can see the average velocity modulus, the magnitude, if you travel by angle theta, is this much. Okay.
Yes, sir.
Now imagine if I say, what will be the average velocity modulus if you traverse the quarter circle? So what will be the answer for quarter circle? And keeping in mind that when we are writing theta, r theta equals to v delta t, the theta is representing the angle in radian. So theta outside in the denominator is in radian.
So the displacement would be r and the time would be same r theta.
For quarter circle, what is the displacement?
R.
For quarter circle, what is the displacement? Can you draw the quarter circle and try to find the displacement?
So it will be under root 2r square, which is r root 2.
Yeah, that's the right answer. So now you know the displacement, which is r root 2. It's a simple Pythagoras. So the base and perpendicular is r and r. So the hypotenuse will be root 2r. That's obvious. And now comes the time interval. How much time it will take to go from there to there? Can you solve for time interval?
Sir, r into pi by 2.
R into pi by 2 upon V, right? R into pi by 2 upon V.
Pi by 2 upon v.
Yeah, that's the right answer. And now what is left is just divide and you will get the answer. Okay. Is this clear?
Yes, sir.
All right. Okay, fine. So if I ask you what is the displacement for a half circle?
2 hours.
2 hours. That's right. And what is the time taken?
Sir, r pi by v.
R pi by V. That's the right answer. So pi r by V. It's a half of circle. So it's a half of perimeter. You can think of that way also. So 2 pi r is the full perimeter. Half will be pi r. So pi r by V is the time interval to go from one end to another. And so the average velocity, the magnitude of average velocity will be 2r by pi r by V, right? Which is like 2 by pi V, right? It's a very famous answer. 2 upon pi into V. Okay, so we'll continue with the same circle, but I will change the problem statement. So let me write down the next one. Now these are the things which will come in most of the competition. They will not ask you, of course, V equals. Why they will ask you V equals V plus 80? Everyone knows that you can solve it. They will ask you something in vector form because vector is something which appears difficult for kids. So competition is all about these kind of problems which are not comfortable with. Okay. So let's do this problem. Same problem. And I just put a problem statement actually. So I put a new statement here. And maybe here it's fine. So for the given problem, find the magnitude of average average acceleration for the duration in which it traverses okay duration when the path traversed subtends subtend and theta. at the center of circle. Okay, fine. So now the same question. Okay, so go ahead. Now this is something interesting. So when you are here at this location, what is your velocity vector? So it is something like this, tangential, right? But when you reach here, your velocity vector will turn like this. But these vectors are not same. So this is v1, this is v2. What is interesting that the mod of v1 is same as mod of v2 is same as v because the speed is constant. So the magnitude of velocity is called speed, which is same all the time. So how we find the acceleration? What is the definition of acceleration? Average acceleration.
Sir, it's velocity final minus velocity initial
So
divided by
delta.
delta t.
So
So I
delta
hope you
V
have,
by delta
yeah,
T.
yeah. So I hope you can now find further from here mod of v2 minus v1. And finding the mod of v2 minus v1 needs three things: their respective magnitude, that is v2, v1 magnitude, which is v we know, and the angle between these two vectors, because that's how we find the difference, the magnitude of difference of two vectors. And finding the angle is pretty easy job because it will come in terms of theta itself. In fact, you will realize that the angle between these two vectors is same as the angle between these two radius. This theta and this theta is always same. You can prove it by the property of quadrilateral. This is 90, 90. So maybe this is first and I should give you the proof. So 90, 90. So what is this angle? Can you guess? The sum of angle of a quadrilateral is 360. So it's theta 90 something 90. What is something part?
So 180 minus theta.
And therefore the what is this angle? Theta. If this is 180 minus
So
theta,
which angle are we finding?
the angle between v2 and v1 vector. What is the angle between v2 and v1 vector?
Oh, ha, sir.
This turns out to be theta itself. Understood? And you can prove it by the property of uh, quadrilateral. Because this angle is pi minus theta, so the other will be theta only. So I hope you know everything what you need to know to solve this problem. So can you tell me the answer now?
Sir, it's v under root 2 plus 2 cos theta upon delta t.
Pardon?
V under root 2 plus 2 cos theta divided by delta t.
It cannot be plus. It must be minus.
Oh, sorry. 2 minus 2 cos theta. No.
And we know that what is so 2 minus 2 cos theta, you can take 2 common, and 1 minus cos theta we have already known that how to write.
Yeah.
So 1 minus cos theta we can always write as 2 sin square theta. In fact, you should remember these two formula all the time because this is very helpful in making something perfectly square. So we can always take it out of the square root sign. So now tell me the answer. Now you know the formula. I have given it. Now you can tell me the answer. Tell me the final answer, please.
Sir, it's 2v sin theta by 2 divided by delta t.
Delta.
T.
But
So
what
I
is
have to
delta?
convert the time. So
Yeah, yeah. So converted to that converting to the given. Okay, we have done this delta t. Delta t is already given to you. So to go from there to there, how much time it will take?
R theta by.
Yeah. So now if you substitute, what is your final answer? I want the final answer.
So it's 4v sine theta by 2 into 1 upon r theta.
No, you guys are making a huge mistake. I mean, the answer should be v square by r sine theta by 2 by theta. This is the answer. Anyone getting this answer?
So yeah, just I got this answer, sir. I did the resolution technique that under root v1 square plus v2 square minus 2. So v is, I mean, both have same magnitude, so
Correct,
it
correct,
will become 2v square minus 2v square cos theta, and cos theta, and we will take v square out, so it will be
correct.
v.
That's right. That's right. That's the right way of doing it. So you will realize that the acceleration coming here, the average acceleration for the duration which we are talking about, is this wonderful nice formula. Okay, I'm not saying that you should mug up the formula, but of course it may be difficult now, but after some time, when your brain will get matured, you will learn a lot of physics. You will find it ridiculous that how easy this was, why we were finding so difficult. So there are certain things which becomes easy with time, but it's good to put as much effort as possible. So kinematics, again, I'm saying kinematics is something which I will personally demand the maximum effort. Like you give everything whatever you have. Like, all the hard work should be there. And very soon you will get a lot of questions. Once theory part will be proceed, you will get more and more questions to solve. But the vector notion of kinematics is the difficult part. The one dimension is will be easier for you, but you have to master this vector notation part. This is the only part which is slightly difficult.
So
Okay,
can you
so
solve after that step?
okay, yeah, I will solve all stuff. I think you guys need this first time. So you can write as formula as v2 square v1 square minus 2v2 v1 cos theta upon r theta by v, because time to and we know that if all v are same magnitude wise, they are same because information means they're not different in magnitude, they're different only in direction. That's why velocity vectors are different, not their magnitude. And so it turns out to be v square v square vv cos theta. And I hope you can get from here. So I can write this is 2v sine theta by 2. And so you'll get the answer v square by r. Okay, so this is the answer. I hope this is clear. Tell me, guys, if you have any doubt
So
in
by
this.
mistakenly I wrote the down denominator part as r theta by 2. So that's what
Okay.
I got.
Hmm. Okay. So next we can go is called the calculation of average speed of journey. So this is again a very interesting and standard problem. Calculation of calculation of average speed of journey So first of all, everything begins with a definition. What is the definition of average speed? Anybody? What is average speed?
So total distance traveled upon total time.
Correct. So total distance traveled upon total time is answer. That's a simple definition. Total distance traveled upon total time. Okay. So you will stick to this definition to arrive at the answer. Do not apply your own brain. Okay. So the first one. So imagine you go from any location A to any location B, and while going, you maintain your vehicle speed as V1. In the return journey, you change your speed to new value V2. Now the journey from A to B and B to A was informed independently. Like the first part is informed A to B and other part is informed B to A. So can we say the entire journey is informed? Can we say the round trip journey is informed?
So
So
what did you
inform.
say?
So you go from A to B with uniform speed V1, but you come back with uniform speed V2. So can I say that the round trip journey was uniform? Yes or no?
So speed means it went with uniform speed and came with uniform speed.
Yeah, I'm asking about the uniform speed only. Like,
Yeah, so
can
it
we
will
say
be
that,
uniform.
can we say that the entire journey was having uniform speed?
Yes, sir.
The answer is no.
No, sir. Yeah, sir. From B it will, yeah. Like from
It is
point B
uniform.
to.
Yeah, it is uniform piecewise. It's called the part-wise uniform, but not as a whole. So as a whole, it's non-uniform speed. So what is the meaning of non-uniform? If the duration of observation will see more than one variety, it's non-uniform. And here we have two varieties, right? So A to B is uniform, B to A is uniform, but A, B, A is non-uniform. Okay, and because it's non-uniform, so there must be some average value. So can you find the average speed for the entire journey, the round trip journey? Find average speed for a round trip journey.
Sir,
Yes.
So
so we have to
distance is
achieve the time of velocity. I mean, the time will be from A to B T and B to A T.
Pardon, A to B will be
T
T.
and B to A will be also T, right?
But how it is possible if you're driving with two different speed, how will reach by the same time? Like you have a car, you can imagine you are going from A to B and you're coming from B to A. So the distance is same in both cases. Speed is
sir
different. So how?
answer is
Yeah, answer is tell me.
sir it's V1 T1 plus V2 T2 upon T1 plus T2.
But I haven't given T1, T2, right? Okay, distance is also not given, so you can assume some value.
Sir,
So assume some
AB.
value. Let's call AB as S or X, whatever.
Sir,
Hmm.
sir, it will be 2x.
Yeah.
2x by it will be 2x by x by v1 plus
Hmm.
x by v2.
Correct. Very good. Now you can simplify because X will cancel out. You can take X common, right?
Yes, sir.
And then X will cancel out. So you'll get something only in terms of V1, V2.
Sir, it's 2v1 v2 upon v1 plus v2.
That's the right answer.
Sir, I
So
thought you gave the time as t1 and t2. That's why I said that.
but I think I didn't give anything. Question is in front of you, and you are supposed to find the answer in terms of V1 and V2 itself, right? Anyway, but that's a nice question, and I hope you have got this answer. So let's do something next, a similar question. So I hope anyone who is not getting the answer, I mean, do I need to explain? Anyone who is finding it difficult, I will explain it. Shristi, you got it?
Yes, sir.
Atharv, Harshit, who is
Sir, I
Atharv?
understood. A second.
Someone has left. I think Atharv Deshpande. Maybe he is left. So find the speed now. So if you all have got this, let's go for the next problem. So imagine if I gave you a journey from only A to B, and the first half you travel with V1, and the second half you travel with V2. So what is the average for the journey A to B?
So distance is same.
Yeah, half. That's why I'm saying the first half and the second half is
The
equal.
same. The same as the
Same half.
first answer.
Correct. So it will have same as the first half. So I want to extend this for a similar pattern. If I make it one third, one third, one third. So if I bring three equal distance, so if I divide the journey into three equal parts, the first part you travel with V1, second you travel with V2, and third you travel with V3. What is the average now?
So we 3 v1 v2 v3 divided by v1 plus v2 plus v3.
No. Okay, you tried very really well, but that's won't be done. So you get a consecutive product of two numbers, 1, 2, 2, 3,
Yeah, so
3, 1. If you uh, take the LCM and if you solve, right? So you can verify by doing it. Can you verify?
yeah, so now I got the same answer.
Okay. Now I will tell you something a simple trick because you need to take the LCM and a better way of writing. So we should not write this way. So we prefer writing this way. So for n equal distance, so let's say if we have V1, V2, dot Vn for n equal intervals of in terms of distance, you can write it like this: n upon V average equals to 1 by V1, 1 by V2. So you can directly apply this formula for any. If it is 2, write 2 by V average, and then write the first two terms. For 3, write the first 3 terms. For 4, write the first 4 terms, and for n, just write the first n terms. That's it. This will solve all question of this nature. In fact, we can go further and we can solve something interesting. So let me write down a new question. Text.
Sir, please
Apart-
show the last screen. Yeah, sir. Done.
A particle travels first half of a journey with speed with uniform speed v1, then one third of a remaining journey with speed uniform speed v2, and a remaining journey with uniform speed v3. Find the average speed of journey. So can you solve this question? So then meanwhile I'll type the next question which you need to solve. So I'll write some. Okay. So this is your question number 2. So first you finish this part, then
Sir, first one answer. Should I say the answer, sir?
Tell me answer.
Sir, 2 by.
Sir, I also got the answer.
Okay, so one by one. First, tell me.
Sir, 2
Answer
by
2 by
9 V3 V2 plus 3 V1 V3 plus 6 V1 V2.
in the numerator, like this.
Numerator.
May I say?
Yeah, sir. V1 V2 V3.
Okay, this is the answer for both of you.
Sir, no, I got different.
Okay, tell me the answer 2.
Sir, it's 6 V1 V2 V3
Hmm.
divided by V1
Mhm.
plus V2. Sorry, V1 V2. Sir, sorry, I promised. Sir,
Yeah.
V1 V2 plus 3 V2 V3
Okay.
plus 2 V3 V1.
This seems to be correct answer. Yeah. And anybody else? Shishi, you want to say something different? Is your answer same? Shishi, are you there? Seems like she is not. She is not attending the lecture.
Hello, sir.
Yes.
Sir, I took the X part, means X first part as X and second part as X, and the V2 has covered 1 by 3, means X by 3
No,
parts, so
no.
X by.
A particle travels first half journey with information given, but then 1/3 of remaining. What does it mean?
Yeah, sir, 1/3 of remaining, so I took half as X, so half is remaining, so X by 3, 1 by 3 part
Yeah,
of
right.
X,
Yeah, correct. And then what is remaining?
2 by 3X,
Yeah. Correct.
2X by
Correct.
3, which is. Sir, yes, then I solved, sir, then I got the above answer.
Yeah. So that should be the right answer. So we
Sir, I
got
took total distance as X.
2x. I think if someone is saying that half is x and half is this is 2x, right? And then you travel the first x by v1, then 1/3 of the second with v2, and 2/3 of the second with. So this is what you should have written, right?
Yeah, sir, I also got the same answer. Means my first step was this, what you have written, and the last step was the what I said.
Okay. Okay. So then what is the answer coming out to be? So the LCM of 133 will be 3 only, right? So the LCM is 3 v1 v2 v3, right? So the first term will be 3 v2 v3 plus v1 v3 plus v1 v2. So I think none of the answer coming to match this. So the answer is yeah, x we consider. So answer is 6 v1 v2 v3 upon 3 v2 v3 plus v1 v3 plus v1 v2. I am getting this answer. Oh,
Sir,
so yeah,
So
that's a
there will
mistake.
be 2 V1 V2.
Yeah, there is a mistake. There is a mistake. Yeah, that's yeah, that is 2 is already there, na? 2 is there.
so then
Correct.
my answer is
So the
correct.
second answer will be right.
Yeah, yeah, this is the right answer.
So what I
Second
did,
was
I took total distance X and then a half distance, so half X plus X by 3 and 1 by 6X.
yeah, that is also correct. That is also you can do that also. Nothing wrong with that. Okay, now the challenging comes. This is the challenging one. So you want to try this problem?
Yes, sir.
Yes, sir.
Go ahead.
Sir, its velocity V0.
Yeah, V naught. It's like V naught.
So can we take distance of x or some?
Yeah, you can take whatever you want.
Sir, answer should be in the terms of velocity itself.
Yes. Only in terms of V0, V1, V2.
So is it V naught?
Yeah, tell me. Tell me the answer.
Sir, I got V naught as answer.
Only V naught.
Yeah, sir.
How could this be possible? Only V naught not an answer, right? Okay, look at this question. This is a difficult question. So the question says that a point travels half the distance. So let's call it this is half. It travels half the distance with V naught. But something different information given. The remaining part of the distance was covered with velocity V1 for half the time. Okay. So let's say you take
So
time
can I
t
say
to
my answer?
yeah, tell me the answer.
So 4v1 v2 v3 upon v2 v naught
Or
plus v1 v naught plus v1 v2
you're saying this one?
divided by v2 v naught
Mhm.
plus v1 v naught plus 2v1 v2.
Okay. Let me check. So now it's saying that you travel half the time with V1 and half the time. So what is interesting that let me remove this part, you can see this later. So the right half x we can write as V1 by 2, V2 t by 2. So from there you can get the t value. So t is how much? 2x by, right? This is what you did. And then you can add the V average, which is 2x upon. The time taken to go from the first half will be x by V naught. And the rest time is t, which we got in terms of x, 2x by. So the answer turns out to be 2 times V1 plus V2 multiplied by V naught upon V1 plus V2 plus 2V. See the answer. Now think about it. What mistake you did?
Sir,
Think
I
about
took
your
every time different, sir. That's why
yeah.
I think.
I know. This is not an easy problem. Of course, this is the second problem from IE Eroder. You just finished the second problem. Eroder. Okay. So we have done a small part. Now there's something remaining. Like okay, maybe I can give you one more question.
I have a doubt.
Pardon?
Sir, means I have a doubt in the previous one topic.
Mhm. Tell me which topic.
Sir, I have a doubt in that part. In the non-uniform velocity part,
Mhm.
where sir,
Which part? Which chapter? Here?
in that
Here. I think here, right?
no, sir,
This is the
yeah, this part.
this one.
So, sir, in this part, no, sir, the slide ahead. Yeah, sir, this part. Sir, in the end right hand side, last point, if a vector follows some mathematical function, then the a vector is equal to dv vector by dt. So,
No, that whether it follows or not, A is always d by dt, but when it will follow, then you can derive something further.
Yeah, sir. That I understood, but I'm not able to understand, sir. That three top points below that
Okay,
flow
okay,
chart.
okay. See, the v vector can be changed in three ways. You change direction, we will change. You change magnitude, we will change. You change both, we will change. And if we will change, A will be there. So in how many ways any vector can be changed? That's the question. So any vector can be changed in three possible ways. You change magnitude, direction, or both. That's true for any vector, right?
Yeah, sir.
So actually, I should have written here, if A follows some mathematical function, then we can derive formula, like some form. That's right. So if it is not having any mathematical function, then we cannot derive a formula. That's the problem. Random is no formula. And if it is not random, it means it will have some formula. But that is actually a disjoint. The context is not actually for this part. This part you can avoid actually. So you can just go back to the, from here you can jump to here. Okay. These are like, I was trying to give some information. So this is the info one, this is info two, and then actually you can go back to here, the third part. So if it is non-informed access, you can directly write here. Okay.
Yes, sir.
So now you come across something called vector equation. So if I give you the position vector of a particle is given by r equals to 2t square I cap plus tj cap minus 3k cap.
So what is PV?
Pardon?
So what is that PV?
What is the PV as a position vector? So position vector of a particle is given by r equals to 2t square I cap tj cap and minus 3k cap. Find displacement in first 2 seconds.
So this
Find,
is a question, no, it's not like a real phenomenon.
pardon? T is time, don't worry.
So it's so no, it's not a real phenomenon, or I mean just a question, a
It is
function.
position, it's a position vector formula, like a function. Function. So position vector of a particle is depending on the time by this formula. Okay. So find the displacement in first 2 seconds. Find velocity at t equals to 1 second. Find acceleration at t equals to 1 second. So these three problems you have to solve.
Sir,
Hmm.
sir, all the answers are root 77, but with different units.
Let me check. All are wrong answers. So first you need to find the displacement, right? So
So
displacement.
first we have to find that. Hello, sir.
Yeah, tell me, tell me.
So first we have to find that no for time equals 2 seconds and time equals 0 seconds. Then we have to
Correct,
subtract
correct,
them and
correct. Very good, very good. So R at t equals to 2 minus R at t equals to 0. And that you can get easily. So 2 means 2 to the 4 to the 8i plus 2j minus 3k minus 0 will be 0, 0, 0 minus 3k. So it turns out to be 8i plus 2j only. And then you can find the magnitude also if you want. Okay, which is 2 root 17. For velocity part, you just need to differentiate. So you get 40 I cap plus t j, sorry, 1 j cap and 0 because 3 is constant, so constant will give you 0. And then I'm finding at 1 second. So v vector at t equals to 1 second will be 4 I cap plus j cap, and so mod of v will be root 70. And the third part is acceleration, which is dv by dt. So first you need to differentiate v, then again differentiate, which will give you just 4 I cap, and it's constant. So the mod of a is constant, so it means at any time it will be same. Was it difficult?
no, sir.
No. So I'm okay ending the lecture here, and we have done with all theory actually. So the next lecture I will start the one dimension motion. So we'll only solve. See, this chapter is actually done. I mean, in a way, theoretically, this is the end of the chapter. But what we are going to learn is called the problem solving techniques. So we are going to solve a variety of problems to get the in-depth idea about this chapter. So all future lecture will be all about solving numericals. Okay. All right.
Yes.